Lecture 10.1 is on circles and circumference. We have a few special segments in a circle. First would be the radius. It's a segment with endpoints at the center and on the circle. Plural of radius would be radii. So in our picture we have CD, CE, and CF all as radii because they start at the center and the other endpoint is on the circle. A chord is going to be a segment with endpoints on the circle, so both endpoints now are on the circle. So if we look, we have AB and DE, both fitting that definition. And lastly, we would have the diameter of a circle, which is a chord that passes through the center and is made up of collinear radii. So DE is the diameter of circle C. You can see it's made up of the radii CE and CD. And since both endpoints of it are on the circle, it's also a chord. So our first problem is to name the circle and identify a radius. To identify a circle, we need to know what the center of that is. So we look at our circle. The center is E. So we know our circle is going to be circle E. And a radius is going to be any segment that has endpoints at the center and on the circle. So if we look, we have BE with segments or with endpoints on the circle and at the center, and along with ED. So our circle is circle E, and the two radii are EB and ED. Our second problem is to identify a chord and a diameter of the circle. Our center point is Q, so we have circle Q. Our chords are going to be any segment that has both endpoints on the circle. So if we look, we have WZ as a segment with both endpoints on the circle. So one chord is going to be chord WZ. Since we know Z is on the circle and X is on the circle, we're going to have XZ as a chord. Same thing with WY. W is on the circle, Y is on the circle, so WY is also a chord. So those are our three chords. We know a diameter is going to be any chord that goes through the center. The two of those that go through the center are WY and XZ. So those are all of our special segments. XZ, WY, and WZ are all chords, and WY and XZ are both diameters. In this problem, we are asked to name the circle and identify a radius. To identify the circle, we need to know what the center point is. We look at the center as F, so we know right away we can eliminate answer D because that doesn't have the correct naming of the circle. Then we need to look for a radius. If we look at our circle, the radius is going to be any segment where the endpoint is at the center and on the circle. So FA would be 1. We would have FN as radius and FT as radius. So then we just need to look at our examples, which one of those is named as a radius, and that would be answer B. So our circle is FN with radius, our circle is F, with radius FN. Here we asked which segment is not a chord, so we need the segment that does not have both endpoints on the circle. So if we look at our circle, we would have AC being a chord, CT being a chord, TN, and AT. So AT we said was a chord, that eliminates A. If we look, CT is a chord, so that eliminates B. And D, TN is also a chord. So that leaves us with our answer of FN not being a chord. We know FN is a radius because one endpoint is at the center and the other is on the circle. Alright, we have a few relationships to talk about as well. The radius and the diameter are always going to relate to each other in the same way. The radius is half the size of the diameter, so we know if a circle has a radius r and diameter d, and r is going to equal d over 2, or r is going to equal half d. Along with that, the diameter is always going to equal 2r because it is twice the size of our radius. Two circles are considered congruent if and only if they have congruent radii. So our example here, if GH is congruent to JK, then circle G is congruent to circle J. Another definition, we have concentric circles. Concentric circles are coplanar circles that have the same center. So circle A with radius AB and circle A with radius AC are concentric because they have the same center point. Finding radius and diameter. If RT is 21 centimeters, what is the length of QV? So we know RT is this segment right here, and that's 21 centimeters. We know RT, since it goes through the center and has endpoints on the circle, it's a diameter. And then if we look, QV starts at the center with one endpoint and the other endpoint is on the circle, so we know that is a radius. And since RT is the diameter and QV is a radius, we know they're going to relate to each other. We know our diameter is going to equal 2 times the radius, so we just plug in what we know. We know RT is the diameter, so D is going to be equal to 21. That's going to equal 2R. So then solving for R, because we want the radius, we want QV, that's just going to be dividing by 2, so our radius is going to be 10.5. Again, QV, since it is a radius, is going to be equal to 10.5 centimeters. If QS is equal to 26 centimeters, what is the length of RV? Again, we need to identify what they give us. QS is a diameter. So if QS equals 26 and RV is a radius, to find RV, we know the diameter is going to be equal to 2 times our radius. So QV is going to equal 2 times the segment RV. To solve for that radius, we just need to divide both sides by 2. So we know our radius is going to equal 13, which would be letter B. Finding measures in intersecting circles. The diameter of circle X is 22 units. The diameter of circle Y is 16 units, and WZ is equal to 5 units. We need to find XY. So first off, we know XY is going to be equal to the sum of XW, WZ, and ZY. So we need to find the segments we don't know. We know WZ is equal to 5 units, so that little section there is going to be 5 units. And we know since the diameter of X is 22, we know XZ is going to be a radius. That's going to be 11 because it's half of that. We know YW is a radius of circle Y. If circle Y is 16 units, then WY is going to have to be 8 units. So now we know from X to Z is going to be 11 units, and from Y to W is going to be 8 units. So we can use all that information to find XW and YZ. So first we're going to find ZY. We know that WZ plus ZY is going to equal WY. So then we plug in what we know there. We know WZ is 5 units. We don't know ZY, but we know WY is going to be 8 units. So then solving for ZY, we know that's going to be 3 units long. So now we know ZY is 3 units. We can use the same process to find XW. We know that's going to be xz plus zy is going to be equal to xy. So we're going to have find the measures in intersecting circles. If the diameter of circle X is 22 units, the diameter of circle Y is 16 units, and WZ equals 5 units, find XY. So first they tell us at the end here WZ is 5 units. So that's useful. We can label that on our picture. WZ is 5 units. Then we know the diameter of circle X is 22 units. But we know in circle X that from the center at X to the end point, or to any endpoint that is on a circle, is going to be a radius. So XZ is a radius of circle X. We know the same thing about circle Y. Circle Y has a radius from Y to W. So we know each one of those radii are going to be half of their respective diameters. So since the diameter of circle Y is 16 units, we know WY is 8 units. Similarly, the diameter of circle X is 22, so XZ is 11 units. So we can use this information to begin solving our problem. We can find ZY. We know since YW equals WZ plus ZY, and WY is our radius, it was 8 units, WZ is 5, we can plug that in, and solving for ZY, we're going to get ZY to equal 3 units. Now that we know ZY is 3 units, and we also have already found out XZ is 11 units, we can find that whole segment by adding together XZ and ZY, because that makes up all of XY. We know XZ is 11, ZY was 3, so then XY is going to equal 14 units. If the diameters of circle D, circle B, and circle A are 4 inches, 9 inches, and 18 inches respectively, find AC. So we know we're looking for AC. AC is made up. AC is going to equal AB plus BC. And that's using our segment addition postulate. We know segment AB right away is going to be a radius of circle B. They told us circle B has a diameter of 9 inches. So if the diameter is 9 inches, we know our diameter equals twice our radius. If the diameter is 9 inches, then that equals twice our radius, so our radius is going to equal 4.5 inches. So that's AB. Now to find all of AC, we just need to find out what segment BC is going to equal. Again, we know BD is going to equal BC plus CD. We're looking for BC, but we know BD again is a radius of circle B, so that's going to equal 4.5. We know CD is a radius of circle D. Circle D has a diameter of 4 inches. So we know the radius of that circle is going to be half of that diameter, so that's going to be 2 inches. So we're going to have BC, which we don't know, plus CD, which is 2 inches. So BC then we know is going to end up being 2.5 inches. We can plug that back into what we know. We're looking for AC. We already said AB was 4.5 inches, because that is the radius of circle B, plus BC, which is 2.5. So AC is going to equal 7 inches, which is answer C. Finding circumference. We know circumference is going to equal pi times our diameter, or pi times d, where d is the diameter. Circumference is also going to equal 2 times pi times r, where r is our radius. It's because our radius is half the size of our diameter. So if we were asked to find the circumference of a circle with radius c, we're just going to plug that in to our second equation here. We know our circumference is going to equal 2 times pi times our radius. So we plug all of that in. We have 2 times pi times 6, so that's going to be 12 pi. Our exact answer would be 12 pi, which is approximately 37.7. If we were asked to find the radius of a circle with the circumference of 31, we're going to do the exact same process except reverse. We know the circumference is going to equal 2 times pi times r, so we plug in what we know. We know the circumference is 31, so 31 is going to equal 2 times pi times r. Solving for r, we need to divide by 2 pi, so our radius is going to equal 31 divided by 2 pi, which is approximately 4.93. The Unisphere is a giant steel globe that sits in Flushing Meadows, Corona Park in Queens, New York. It has a diameter of 120 feet. Find its circumference. We know circumference equals pi times our diameter. So our circumference is going to equal pi times 120. Plug that into our calculator. C is going to equal pi times 120, which is approximately 377.0 feet, which is answer A. Find the radius of a circle to the nearest hundredth if its circumference is 16.8 meters. So we know circumference equals 2 times pi times r. They tell us the circumference is 16.8 meters. That's going to equal 2 pi r. Solving for r, we need to divide both sides by 2 pi. So our radius is going to equal 16.8 divided by 2 pi, which is approximately 2.67, which is answer C. Find the exact circumference of circle K. So if we look at circle K, we have a right triangle with a hypotenuse of 3 times the square root of 2, but we notice the other two legs of this triangle here are made up of segments that start at the center and end on the circle. So we know both of these are radii. We know all radii of the same circle are going to be equal, so these two segments are congruent to each other. So since all radii of a circle have the same length, we can call both of those legs x if we want to. Since it's a right triangle, we can use the Pythagorean theorem. So we know a squared plus b squared equals c squared, but we know both of the legs are the same length, and we call them x. So really we have x squared plus x squared equals 3 times the square root of 2 squared. So then we have 2x squared is going to equal 18. So x squared is going to equal 9. And square rooting both sides, x is going to equal 3. So we know the radius of this equals 3, but we're not asked to find the radius, we're asked to find the circumference. So we know circumference is going to be 2 times pi times r. So the circumference of our circle is going to be 2 times pi times 3, which is 6 pi. 6 pi is our exact answer. We didn't round off any decimals. So we leave it as 6 pi when they ask for the exact solution. Find the exact circumference of circle B. So again, we have right triangles in our circle. So we need to find the radius or the diameter of that circle. So if we know that both legs of B are radii, then we know that they are congruent to each other. So they're going to be equal. If two legs of a right triangle are equal to each other, we know this is a right triangle, then we know that these two angles have to be equal to each other. And if this is going to be a right triangle with two equal angles, we know we have a special right triangle here. We have a 45, 45, 90. So we know in our normal 45, 45, 90s, we would label the hypotenuse as x times the square root of 2 and the other two sides as x. So they give us the hypotenuse of that triangle to be 10. So we know 10 equals x times the square root of 2. So to solve for either one of those legs, we need to divide by the square root of 2. So x is going to equal 10 over the square root of 2, but we rationalize that diameter by multiplying by the square root of 2 over 2. So x is going to equal 5 times the square root of 2. And that's just this one part right here. We've got 5 times the square root of 2. So to find the circumference of our circle, we are going to multiply 2 times pi times our radius. So our circumference is going to equal 2 pi times 5 square roots of 2, which is going to equal 10 square roots of 2 times pi, which is answer C. And that wraps up